All right, so this is the last day of new stuff. So we are adding lots of things, but today it finally ends. Just as a review, let's find the derivative of arcsine of x over 2. So let's see, arcsine, that's definitely has a square root in the bottom. It has a minus sign. And arcsine, sign's always between -1 and 1, so it's a small number, so I'll do 1 minus the argument squared, and then times 1/2 for the chain rule. Okay, as a safe stop, that's fine. If we wanted to do some algebra cleanup work, let's see, 1 over 2 square root 1 minus x squared over 4. You okay with that? This 2 went to there, and I squared the x over 2. Now, the next step is legitimate. It's just maybe confusing. I would like to distribute that 2 into the square root, but I can't really do that because this one's not a square root. So what's another way to write 2 as the square root of something? That's the square root of 4. So I'm just going to rewrite 2 as square root of 4. And that's weird, but I did that so that I can now distribute that into the square root and get something that looks a lot nicer. So a little bit of algebra gymnastics there, algebra trickery, which we would not normally do, right? Normally, if we had the choice, we would safe stop way back here and call it a day. But it might be multiple choice, so we might want to be able to get to there. We also are setting up the next question. This means if I want the antiderivative of what I just got, so I took the derivative of this and landed here. Now I want to go backwards from here. Where am I going to land? Right back there. Arcsine of x over 2. Okay, so let's see if we can follow the pattern here. This example over here, it definitely looks like arcsine because it's something minus x squared with the square root. So definitely arcsine x over 3. Oh, I guess I need to put a plus c on these since I'm doing antiderivatives now. You okay with where that 3 came from? Because this was 2 squared was 4, and this is 3 squared. How about this next one? Square root of 7. I'm getting kind of weird, but that's fine. X over square root of 7. What about the next one? Arcsine of x over a. And congratulations, what you sort of just backed your way into is the formula for the antiderivative of du over square root of a squared minus u squared. Arcsine u over a plus c. Again, the hope is that you don't memorize them separately, like derivatives and antiderivatives. The hope is you know the derivatives well enough that you look at that and you're like, that looks like arcsine. And so then you got to remember how to handle the u and the a. Speaking of looks familiar, which one does that second one look like? It looks like arctangent, and it is arctangent. Now, if you had to guess what the rest of it was, what would you guess? You'd be close to right. It is u over a. But there's a tricky thing about arctangent that's different than arcsine. There's a 1 over a out front. well, we're running out of choices here, but also what does that last one look like? Looks like arcsecant. Again, u over a. That one also has a 1 over a out front. Now there's this little side note there. Integrals yielding arcsecant function are not tested on the AP exam or Mr. Wolf's exam. So you can kind of, you don't have to memorize that one, but I wanted to show it to you to see the parallels between the two. So you won't ever have to go backwards and land at an arcsecant. You still have to kind of know it because we will ask you to move it forwards, like to take a derivative of arcsecant. So you can lightly mark it out because I'm not specifically going to ask that, but I can ask it in the derivative direction. So the main difference is if you know the derivative rules, it's easy to spot which one is sine and which one is tangent. The main difference is that 1 over a out front. How I always remembered it is tangent has, like the word tangent has an a in it, so it gets the extra 1 over a out front. Sine doesn't have an a, so no a out front. So that was quick. Thank you.
So we found the nail, but it was too small to actually puncture your tire.
Okay.
Yeah, so it wasn't leaking. We just aired them all up, and you're good to go.
Awesome. Thank you.
You're welcome.
Fantastic. Okay, so that's, I don't want to say that's it for today. That's a lot. Let's try number 1. So job 1 is to first, before you get into the details, recognize which one it is. So before we worry about U's and A's and who's are out front, what's the big picture? What's going on here? Pretty sure that's sine, or arcsine, I should say. So we recognize that that looks like an arcsine problem. So I would really like it to be a squared and u squared. So a is 5, that's an easy one. What would u be if u squared is 4x squared? Good, u is 2x. Oh, I bet you can know what we're about to do. If u is 2x, almost every time we've used the u substitution, what did we do next? du. So what's du? 2 dx. All right, I can handle that. Fix it with a 2. So now I've got 1/2 antiderivative du square root a squared minus u squared. And now it matches exactly the arcsine. So initially we recognized it as arcsine just because of the square root and the minus, like we could see what was going on. Now we've cleaned it up and it's exactly arcsine. So 1 over 2 arcsine. I guess I could just say u over a, since as long as I've said what u is and what a is, it'd be good. Multiple choice is certainly going to replace u and a. But if you've told me what u and a are, then you can leave the u and the a in there. Again, this is definitely, like yesterday and today are kind of like partner lessons, because yesterday was take a derivative, today is take an antiderivative. Number 2, what's that look like? Looks like arctangent. It's a 2 instead of a 1, but we can fix that. So it's definitely arctangent, which means I want u squared plus a squared down there. Whenever u is just x, you kind of don't need to worry about it. So it's up to you if you want to write it or not. What's a going to equal? 2. What do I do with that 3 that's up there? Yeah, just move it to the front. So, well, I guess we can go the long way here. So that means u is x, du is dx. So that doesn't really do a whole lot. But if you wanted to really make it look nice, it's du over u squared plus a squared with the 3 out front. So 3 arctan, I intentionally left a little space there, u over a plus c, because what else needs to go there? The 1 over a. And again, as long as you've said what u and a are, you can leave that. 3 over root 2 arctan x over root 2 plus c. Again, you know the arcsine and arctangent derivatives. Today's not too bad working backwards. I say that, and then we hit one like number 3. So what do we think? Arcsine would have a square root somewhere. So I think it's arctangent. I'm a little less sure on this one. So arctangent, question mark? If it's arctangent, I need a squared and u squared. So a square root of 7, that's easy enough. What would u need to be? I'm also kind of worried about that sign up there, but if u squared is cosine squared, u is cosine, and the derivative of cosine? Negative sine. Okay, that's good. So now I've got the top taken care of, meaning all of that's du. So du over a squared plus u squared. So I'm changing my question mark to an exclamation point because that is definitely arctangent. So negative 1 over a arctan u over a plus c. Right, because I've said what u is and what a is, so that's an okay answer. How about number 4? What does number 4 look like? Arcsine, because it looks like maybe an a squared minus u squared down there. So arcsine, question mark initially, because I've got an x in the top, so I need to figure out where that came from. A is 3. What would u need to be? If u squared is x to the 4th, if we even show an extra step here, if u squared is x to the 4th, then u is x squared. du is 2x, and now I understand where that x is, or comes from, that's in the top. So 1/2 du over square root of a squared minus u squared. So that's definitely arcsine. Exclamation point. And so it's arcsine of u over a. The 1/2 still out front though. And I've defined u and I've defined a, so just x squared over 3. Oh, I said I was going to leave it and then I just plugged it in on the fly there. Questions? So yes, you're not going to get an answer of arcsecant. I can ask you for the derivative of arcsecant, so be careful, but you're not going to get an answer of arcsecant. So that means they're all arcsine and arctangent. Speaking of, what's number 5 look like? Well, maybe this is why Ava asked. So the x out there maybe baits you into thinking, hey, that's like arcsecant. But the rest of it doesn't look like arcsecant because it's 1 minus. So 1 minus looks like it's arcsine. Again, there's the first time through, it's still like, well, arcsine maybe. I would have to figure out what the heck this x is doing there. How did that get there? But this would be a squared minus u squared. A is 1, so that's easy to deal with. What does that mean u is? Natural log. That's weird. Maybe. What's the derivative of natural log? 1 over x. Does that now make the rest of the problem fit together? Yeah, that's why that 1 over x is there. So now we've got du. And then a squared minus u squared. So arc sine. I can write u over a, or I can fill it in. Natural log of x over 1, doesn't do anything, plus c. Kind of a weird one. What does number 6 look like? So this one looks like arctan, but it would really look better if it looked like this. And so to make it look like this, I need to complete the square. So do you remember what needs to go in this blank right there? Half it, square it, add it. Good job, Avery had a good pre-cal teacher. That's right. If you didn't remember that, your pre-cal teacher clearly was lacking. So I can put a plus 4 there. Half it, square it, add it. Half of b, square it, and add it. Although I need to be careful, I can't just go sticking a plus 4 in there. That's not. So I could add it to the other side if it was an equation. Instead, I'm just going to subtract it from the 13. Well, it would just cancel out, but if I added all those, I would get back to this. But I want to group it so that now that's x plus 2 squared plus 9. And now that definitely looks like arctangent.
That seems like.
Why did I have to do that? I wanted it to look like number 6, basically. Because I want a u squared and an a squared.
Do you do that for every one? Do you put a negative at the end?
So the other way to do that is if you know that it's just 4 that's needed there. Some people just sort of split up the 13 into 4 and 9. If you know you need a 4. Yeah, I know. That one's like, well, how did you know you needed a 4? Well, you half it, squared it, add it. Arctan. Okay, so I'm shortcutting this one. I've not said what a and u are, so I'm just going to jump to x plus 2 over 3. Yes, that one's tricky. Complete the square there. Okay, so the next one looks even worse, maybe, because it's 4th squared. So I'm thinking it's going to be x squared, something squared, plus something else. So I'm still thinking arctan on this thing, because there's no square root. So if I half it, square it, add it, 4th minus 6 squared plus something plus 13, and then minus that same thing. So what should what do I get when I half it, square it, add it? Half of 6 is 3. Square it. I get. Yep. Wait. 6 divided by 2 is 3.
Half of 6. Oh, half.
Your brain's doing too much in your head. I don't know what you're doing. Half of 6 is 3. 3 squared is 9. So this is x squared minus 3 in there, and then a plus 4 on the outside.
Because they just divided it to the things.
So what should I let u be? If I think this is an arc tangent, then I need to let u be x squared minus 3. But that's okay, because there was this x floating in the top that I wasn't sure what was going on there. But now I see, why is that x there? Where did that come from? Yeah, du is 2x. This is sort of the chain rule part of the problem. Du is 2x. So I put a 2 up there and a 1/2 out front. And now my top is du. So that was a lot of work, but I'm now definitely looking at an arctangent problem. Be careful, I haven't labeled a yet, so a equals 2, and then I can just answer everything in terms of a. Oof. Those complete the square problems. Yuck. So today's assignment is worksheet 6. We peeked ahead at this yesterday. Let's do it again. What's number 1 going to be? I'm not going to work it, but just what do we think number 1 is? Where are we headed for that one? Arc sine. How about number 2? Arc sine. Number 3? I think it's still arc sine, because there's not, where you're never, they're all arc sine and arctangent. There's a square root, so it's going to be arc sine.
That's the easy way to know. Number 6 on the homework
Would it be
yesterday.
possible to
No.
Okay, so we can just be like,
Okay, you said something when we were solving one of the problems about like how you know that one was arc sine, about it was like smaller than something.
I get confused on whether it's 1 minus x squared or x squared minus 1 in the square root. Because sine is 1 and secant's the other.
Sine is 6.
Sine is 1 minus x squared. Secant is x squared minus 1. Because sine is always a small number. So you need to do 1 minus a small number. Let's peek ahead at number 6. What do we think number 6 is? Is number 6 looks like arctan, but there's this extra t in the top. So we'll have to figure out where that came from. If it's arcsine, or excuse me, arctangent, what is u going to be to make this work? T squared, and now I know where that t from there came from. So 2 and 1/2. And so now I've got, as long as I say a is 5, that's definitely arctangent. And I can answer the arctangent with u's and a's because I've said what u and a are. Oops. What about number 8? What big picture, what do we think is going on? Arctangent. I like that. I think there's an e to the x in the top. Like, where did that come from? If u squared is e to the 2x, what does u equal? E to the x. And then does that make sense of that e to the x in the top? So yeah, there's e to the x's all over the place, but e to the x dx, that's du. And then this one, you'd have to plug in some limits and just change the limits. What about number 9? What would you do on number 9? Complete the square, and what are we headed toward? What's the answer going to be? Arctangent. Number 10, what's number 10 going to be? Arcsine, because the square root of 1 minus x squared. Unless you want to switch everything back to x's and then leave them there. But we've always been changing them, so I'm going to change them. What's e to the natural log 5? It's kind of weird. E and natural log cancel each other out, so that's just 5. E to the 0 is 1, so that turns into easier limits. Arctan of u over a from 1 to 5. This is going to be a weird answer. You're just going to say arctan of 5 minus arctan of 1. Well, I left it off because a is 1. So, you could put it, but it wouldn't do anything. I know what the arctan of 1 is, but I don't have to complete this any further than that. I do not know what the arctan of 5 is. It is not like a unit circle thing. Number 11, where are we headed with that one? Arcsine, square root of 1 minus something squared. So, obviously there's more work to do, but pretty sure that's an arcsine problem. How about number 12? Arctan with a complete the square. So it's probably not answer choice A. It's arctangent of something. 13? If you say it's arctan, I think I agree with you. What is u going to be? E to the x minus 1. And then du is e to the x. So yeah, that all fits. (14, 15). So I think you're on your way here. Work to be done, but it's just recognizing the difference between arcsine and arctan. Now, the trick is going to happen when we get to worksheet 7, and they're all jumbled up. In fact, let's flip over to worksheet 7. Let's look at number 4. Let's just throw our brains off here. What do you think number 4 is? So, it kind of looks like arctangent because of the denominator, but that x in there is going to be messed up. So if you want to do u substitution, what would you let u be? I would do x squared plus 2, and then du is 2x. So I can fix that. So now I've got 1/2 antiderivative du over u. What's the antiderivative of du over u? Natural log. So that x up there changed it from an arctangent problem to a u substitution problem. But if that x had not been there, like number 7, what's number 7 going to be? There certainly is. Good call. Peeking ahead at number 7? That one's going to be arctan. And u will be just x. But that's the tricky part, telling the difference between number 4 and number 7. That's for next week. Rewind. Worksheet 6, all your answers are either arcsine or arctangent.
from worksheet 5.
Number 6 on worksheet 5. Oh, it's so ugly, but yes, I can.